Here's an example of a function, and they want us to find the y-intercept, the x-intercepts, and what happens is x goes to positive and negative infinity. So let's start. Let's write the function down here. And they're asking us, what are the y-intercepts? How do we find y-intercept, or just in this case y-intercept? How do we find a y-intercept? Well, think about a graph for a minute. If you have a graph, oops, that wasn't such a good line. There we go. If you have a graph, a y-intercept, if the graph cruises like this is a y-intercept point. And think about his coordinates. He must be over 0 up some number, right? If he's right there on the y-axis, which means his x value is 0, notice. So at a y-intercept, you set x equal to 0, or plug in, I'm going to call it that way, plug in x equals 0. A y-intercept, by its very nature, being on the y-axis, must have an x value of 0. So I plug in 0, and I get 0 minus 1 squared, oops, 0 minus 8, and that comes out to be what? Negative 1 squared times negative 8, and that is 1, positive 1, times negative 8, so that's negative 8. So the y-intercept is negative 8. They just want they don't want the ordered pair 0, negative 8. They just want the negative 8 part there. So there's the y-intercept. Now, over here, let's do the x-intercept. Now, here's an x-intercept on any old random graph. What do you notice about that? That must be over some number, the coordinates up 0. The y-coordinate, notice, must be 0 at an x-intercept. It's the very nature of being an x-intercept. You're on the x-axis, which means your y value is 0. So we set y equal to 0. So do you see the pattern? For intercepts, the opposite letter is 0. For an x-intercept, for a y-intercept, x is 0, and for an x-intercept, y is 0. It's the very nature of what it means to be an x or y-intercept. The opposite letter is 0. So if you're asked to find a y-intercept, you plug in x0. If you're asked to find an x-intercept, you plug in y0. So I take the equation p of x equals x minus 1 squared times x minus 8, and I'm going to plug in y equals 0. Now where's y? This is y, right? The function values are always the y values. That's by common agreement in the math science world. Functions, f of x, g of x, p of x, that's our y value. That is defined to be y on a graph. So that's my 0. So which values of x are going to make that 0? Well, you set each one of these equal to 0 separately. Because if two things are multiplying, timesing, to equal 0, then either one could be 0 alone to make that true. How do we get rid of the square, the second power? We root it, and so this is just x minus 1. Square root of 0 is just 0. Then just add the 1. So x is 1. Over here, just add the 8. The parentheses aren't doing anything. So 1 and 8 are our two x-intercepts. Pretty much could have seen it right here. If you plug in 1, it's going to make this guy 0. Plug in 8, it's going to make that guy 0. If you make either one of those 0, they're times, so it'll equal 0. So 1 and 8 are the two x values that are the x-intercepts, 1 comma 8. Oh, no, I guess it's 1 here and 8 there. They want you to put the lower one first and the higher one, they're saying. Now, as x goes to infinity, what does y do? Okay, so this is often tricky. Let me help with this. So come on down here. So again, we have the function p of x equals x minus 1 squared times x minus 8. As x goes to infinity. What are we talking about there? Well, we mean if you plug infinity in for x, what's going to happen to the function? Well, we can't really, infinity's not really a number. How can we do that? Right, it's not. So just plug in a really big number, like how about 100? Just plug in 100 for x and see what you get. So p of 100, so plug in positive 100. When they ask you about x going to infinity, just plug in positive 100 and see what you get. Try to get a feel. 100 minus 1 squared times 100 minus 8. What is that? That's 99 squared times 92. I don't know what that number is, but it's positive huge. It's basically positive infinity. You see, y is headed, right? Function values are y values. Y is headed to positive infinity. Now, let's come down here and say, okay, how about, so that was our first answer. This would be positive infinity. Oh, they've already got the infinity, huh? They just want the plus sign. There's the infinity already. Okay, now, what about as x goes to negative infinity? Well, just plug in negative 100. X equals negative 100. So I'll take the function p of x equals x minus 1 squared times x minus 8 and plug in negative 100 right there and there. So I get negative 100 minus 1 squared times negative 100 minus 8. And so what's that? Negative 101 squared times negative 108. This is going to be positive huge, right, because it's squared. This is going to be negative 108. And so positive times negative is negative huge, right? A positive number times a negative is negative huge, meaning it's negative infinity. So y, the function value of y, is headed to negative infinity, is our answer on that. So we just come on up and we put a negative, and the infinity's already there. So does that make sense? When they're asking you about x going to infinity or negative infinity, just plug in positive 100 or negative 100 to the function and just see what it's doing. Are the function values getting really big, positive infinity, or getting really small, negative infinity?